Alrighty, so 8x equals 3x minus 10. So there's a number of ways of doing this, but really the most efficient way is to think, I want to get x's on one side, like the letters on one side, and numbers on the other. So like x equals something. So we have an x term here, an x term here, and a number here, right? So in other words, you might think, well, I want to isolate that negative 10. I want to leave that negative 10 on its own. So what is in the way? Why isn't the negative 10 on its own? Because what's beside it? The 3x. And how do you get rid of the 3x? Good. Subtract 3x. If you subtract 3x, you'll get rid of that, and it'll take that problem out of your life. And you can subtract 3x from the other side also. 3x minus 3x is 0. See that? And so we did that because we then end up with just negative 10 on its own there. Now 8x minus 3x is what? It's just 5x. It's kind of like saying, what's 8 apples subtract 3 apples? What's that? 5 apples. What's 8 bananas subtract 3 bananas? 5 bananas. 8x subtract 3x, 5x. So we have 5x equals negative 10. And that, by the way, is 5 times x. So how do you get x on its own? You're right. Divide by 5. 5x divided by 5. These 5's cross cancel and you get 1x, or just x. Now if you divide this side by 5, you must also divide this side by 5. And so negative 10 over 5 is? Yeah, x equals negative 2. Now let's check that for fun. Because so 8 times x equals 3 times x minus 10, and x we thought was negative 2. Okay, so what's 8 times negative 2? Good, negative 16. What's 3 times negative 2? Yeah, and what's negative 6 minus 10? Ah, see that? We have negative 16 equals negative 16. So both sides are the same, and so that's why that's correct. Now, do we want to try a different way, or are we good with that? Sounds good. Okay.